Gabriel, you guys all look hot today. Shall we do the last one? Yeah, Are you almost done with your session?
My textbook is in
Oh, okay. Did you guys get number 2? Remember when a lot of people hear the word, they think it's something bad? You remember? You were so close. Say it again. Radiation. Ah, there we go. Guys, alright, class! Yes! Class! Yes! Let's go ahead and go over these. I know some of you are done, some of you are still trying to figure it out, but I know some of you were absent as well. So let's go ahead and go over them. If you have any questions, just ask along the way. And I do have a few extra questions that I'm going to ask you, okay? So be prepared. So number 1 should be the easy one. I saw a lot of you looking at your projects to make sure you got them all. What are some of the waves that are part of the electromagnetic spectrum? Punch! Visible light. Let's get another one from somebody else. Yeah, Yuta. Radio waves. Lakshita.
X-rays.
X-rays. Andrew.
Gamma rays.
Gamma rays. Alright. Angela.
Microwave.
Microwaves. We're getting close to the end. Sanj.
Ultraviolet rays.
Yeah, I'm going to put that UV. Alright, Justin.
Infrared.
Good. That's it. Alright, very nice job, guys. Which one kind of falls in the middle of all of them?
Visible
Yeah, the visible light. And what's special about visible light? Yeah, Long.
You can see it.
Yeah, it's the only one that we can see. What colors make up visible light? Yeah, Andrew?
Rainbow.
Yeah, the rainbows. Anybody know the order of the rainbow?
Oh!
Yeah, Alessandra?
Red, orange, yellow, green,
Indigo.
blue, violet, indigo. Or
Indigo violet. And some people will argue that indigo doesn't belong in there, but I like indigo, so we're going to keep
What
it
color
in
is
there.
indigo?
It's kind of like a turquoise. Yep, kind of like a teal aqua color. Alright, so, next question. It's important about gamma rays. Alan.
They're the strongest.
Yeah, they're the strongest. What do you mean by the strongest? What do they have the most of? Sanj? Yeah, they have the largest frequency, which means that they have a lot of what? Energy. So, big frequency, lots of energy. Too much. What happens if you expose yourself to gamma rays? Justin. You become the Incredible Hulk. But in real life, what could happen? Yeah, Andrew?
It's going to penetrate your skin and damage your cells.
Yeah, it's going to damage your cells. You guys remember that word that I used the other day for when it damages your cells and changes your DNA? It's what caused the Incredible Hulk to become the Incredible Hulk. Starts with an M. Yeah, so mutation. So you guys you'll learn all about that in 8th grade, so we won't talk about that too much. Alright, what is special about, let's see here, let's go X-rays. What do you need to be careful of when you get X-rays? What are your jobs?
You can't expose yourself to too much X-ray.
Yeah, you don't want to expose yourself. So what happens when you go to the doctor or the dentist and you get an X-ray? Sophie?
You have to wear the mask.
Yeah, you have to wear that big, bulky vest. And what does the doctor or the nurse do when you get your x-ray? Are they in the room with you?
No.
No, where do they go?
Outside.
Yeah, they go outside because they don't want to be exposed to it either. Okay? UV waves. We all know about these. What do we need to do in order to make sure that we're not exposed too much to those? Sanj?
You have to wear sunblock.
Yeah, wear sunblock. How many of you guys wear sunblock a lot? A lot of the ones who are a little bit lighter skin. That's good.
Sophie's not light.
Huh?
Sophie's Asian.
So that's okay. It's still good for everybody to wear sunblock. Those of you who do have a little bit darker of a skin, it won't hurt you as much because you've got pigment that will kind of reflect it, but you still want to be careful. Alright, ooh, I spelled this one wrong. What's cool about infrared?
You can see red there.
Alessandra?
It's before red.
Yeah, it's right before red in the visible light spectrum. And what kind of things do we use that use infrared technology? Lon?
Heat sensors?
Yeah, heat sensors. A lot like the cameras that we have outside. Alright? We're going to get to infrared a little bit later. And the other ones you guys are pretty familiar with, radio waves and microwaves. Alright, so number 2. What do all of these have in common? Gabriel?
They can go through any medium.
Yeah, they can go through any medium. In fact, do they need a medium?
No.
Yeah, they don't need a medium. So where can they travel?
Anywhere.
Even more importantly, space. So where do we get a lot of these electromagnetic waves?
What's a medium again?
Yeah, medium's something that it can travel through. So it might be a gas or a liquid or a solid, but they don't need any of that to travel.
Okay.
Okay, they can go through space. What's another thing they share in common? Yes, Jonathan?
They all are at the speed of light.
Yeah, they all go the speed of light. Which is really, really fast. Yes.
There are also all types of radiation.
Yeah, that was my next question. They're all types of radiation. So next time you hear that word radiation, I don't want you guys to think bad things because in the news, a lot of the times they make it sound bad. You're around radiation all the time. And it's okay, you will not become the incredible. Alright. Number 3. Alright. All of these are waves, and some properties of waves, which you guys will get into even more next year, are that they have a wavelength and a frequency. And we've looked at both of those. What happens to the frequency of a wave? If the wavelength goes up, so the further they're apart. Yeah, Sophie?
Decreases.
Yeah, it decreases. So, frequency goes up, wavelength is going to go down. Again, you guys already told me which one everybody has the biggest frequency.
Gamma ray.
The gamma rays gives lots of energy. Alright, and number 4, just an application of some of these, the infrared cameras. They can see heat. What color is something in an infrared camera if it's hot? Yeah, Joss?
Reddish orange.
Yeah, reddish orange. And what color is it going to be if it's kind of cold? So, yeah, bluish, purple. Yeah, Andrew? Yeah.
Also purple.
Yeah, bluish and purple. Okay? One other question for you guys. This one might be a little bit of a thinker here. I mentioned it the other day. What unit are we in right now? Weather. Right? There are certain parts of the electromagnetic spectrum that play a bigger part in weather than the other ones. Do you remember the 3? Okay, think about it for a little bit. What's 3 are going to play a big part in weather? Everybody a chance? What 3? Alright, Jenny, what do you think is one?
I think it's visible light.
Yes, definitely. Because where do we get visible light?
Sun.
The sun, and we know that that plays a really big part. Visible light. It's another one. Justin. Not radio waves.
Gamma rays.
Charles?
UV rays.
Yeah, UV waves. Because where do we get those?
Sun.
The sun again.
Good job.
Okay? And the last one, Alessandra?
Infrared.
Yeah, the infrared. The ones that are right in the middle. And what is infrared? Yeah, it's heat. Where do we get our heat from?
Sun.
The sun. So what do these all have in common?
They're all related to the sun.
Yeah, they're all related to the sun. So the sun plays a really big part in weather. So what we're going to look at today is we're going to see, in particular, we're going to be looking at infrared radiation and how it can affect the weather. Okay? So I need you guys to go ahead and put your questions away. Now I'm going to show you guys a picture of the Earth. There it is.
Whoa.
That is hot. What is that? What's hot?
Equator.
Yeah, the area right around the equator. How do we know that it's hot from this picture? Yeah, Alessandra?
Because it's reddish color.
Yeah, so what kind of camera was used to pick up all of this heat?
Infrared.
Yeah, an infrared camera. But what do you notice as you go away from the equator? Charles?
It goes more bluish, and which means it turns colder.
Yeah, it turns bluish or purplish, so it gets a little bit colder. And we all know that. We know that it's hot around the equator and that it's colder away at the poles. But, question for you guys. What causes all of this? This is the easy part too. Angela? The sun. Alright? One thing that this map doesn't show is how the sun can affect different areas within the areas that we see up here. So for example, right now, it's only showing, woo, no. And computer's not cooperating today.
We can use ours.
That's okay. I think it's because Mr. Brunner was changing my computer the other day, and he changed it so it goes to sleep really quickly. Alright, but anyway, this only shows the water. It leaves out on purpose, because I don't want you guys to know what it looks like on land. Alright, and that's because land has lots of different landforms on it, lots of different features. So what our lab is going to be today is seeing how some of these different features will heat up more than others. Alright, so I'm going to go ahead and pass out the lab to you guys. It's called the radiation lab.
Is it groups?
Of course it's groups.
Huzzah!
Huzzah! Here you go, Alan. No, because I want everybody to make their own hypothesis as part of it.
Do we have things?
No, groups.
Pass it back to me.
I'm going to send 5 backs for Sophie. There you go.
That one was for John.
Alright, so can I have a volunteer read the first part up at the top under radiation? Me. Justin, go ahead, buddy.
When something is warm, it gives off infrared radiation. When you put your hand next to a stove or stand next to a fire, you can easily feel the heat without touching the object. This is infrared radiation, and it can pass through any type of object, even space. Even though you can't see infrared radiation, you can feel it as heat. Another example of radiation is UV light from the sun causing sunburn. Radiation is a direct transfer of energy by electromagnetic waves.
Fantastic. Alright, so some of that stuff you guys already went over during the warm-up. Doesn't need a medium, it can travel through space. Alright, and it's part of the electromagnetic spectrum. So what we're going to be looking at today is trying to figure out, when we look at this map, how different areas of the land might heat up differently, depending on where they are. Yeah, Calvin?
But sometimes you can see the radiation from the fire. Like, you can see the heat waves.
You can see the heat waves, but you're not actually seeing the energy part of it. You're just seeing some of the matter reacting to it. So
Okay.
that's good. Yeah. Alright, so what we're going to be doing is we're going to be taking a look at 3 different beakers that we're going to fill with different stuff. Alright, one of them is going to be full of sand. right? Because that's something in front of there. One's going to be full of water, and another one's just going to be full of nothing. What do you think that's going to represent? Air. Okay? Not H2O. All right, then it's a very simple lab. We're just going to figure out the heat or the temperature of these three things over a 10-minute period. All right, so there's nothing too fancy about it. No chemicals are involved, which I know you guys will miss because we just got done with the chemistry unit. But very simple, so you should be able to work through with your group pretty easily. Okay? But our most important thing, since we're doing an experiment, we need to create a what before we start? Hypothesis. So there is a spot right there. Alright, and our purpose, once again, is to see what heats up faster by radiation, so by heat. Sand, water, or air. Now, how do we write a hypothesis again?
If and then.
Yeah, if-then statement. So, everybody's going to write the first part the same. What's an example of how we can do the if part? Anybody want to give anybody some hints? Yeah, Charles?
If we heat up air, sand, or water, then
Exactly. Then you guys are going to fill in the blank. Then will heat up faster. Or you could decide that it makes no difference. Maybe they all heat up the same. Maybe none of them will heat up at all. They'll just stay the same temperature. It's all up to you guys. So right where it says hypothesis, you guys are going to write, if we heat up sand, water, and air, like Charles said, then it's going to happen. Yeah, you're going to put blank is going to heat up the fastest, or they're going to all heat up the same. Right there, Jen.
Can you put black?
No, don't put black. We got sand, water, or air. Think back to our chemistry unit when we talked about solids, liquids, and gases.
Well, how do you even heat up air? You can't even see anything. Unless you trap it. Okay.
no, but if you heat up air, like you can feel like if it's 40 degrees.
No, you can't. Fire. No water.
Yeah,
I mean, water is fast. Water's fast.
Yeah. And then you get to pick which one.
What do you mean? What's the fast? The sand or the
Go ahead.
water heats up really slowly.
All right. Yes. Let's take a vote. See what you guys thought. Who thought that sand is gonna go the fastest? Go ahead, hands up. Anybody think water?
Me. They think
All
air.
right, water now. Who thinks air? Hands up. Anybody think there's not going to be a difference? Alright, so what we're going to go do is I'm going to put you guys into groups. I have 6 groups set up. Alright, each of them, so we're going to look at a second variable. Each of them has a different type of heat source. So not only are we going to see whether sand, water, or air heats up the fastest, we're also going to see what heat source makes it heat up the fastest as well. So I have one of the, I'm sure a lot of you have them at home, especially during the winter, one of the big heaters, the big oil ones. Do you guys know what I'm talking about? That one I've had on for maybe an hour and a half by now, so it's been heating up for a while. I've got one of the little ones, kind of looks like an alien, but it's got the wires that heat up that are really red. I got one of those. I'm going to talk about that one in a little bit as far as safety. And then I have some of the hot plates. I have 2 of them kind of set up like this. And I have, I don't know if you guys noticed, we usually have those little AC heat units that are in the window. I have 2 of those in there as well. It doesn't matter which one you go to, so don't argue over that. Alright? But all you're going to do is every minute you are going to write down the temperature. It's going to be in degrees Celsius. Okay? Just as it says on here. And then by the end you'll be able to tell, and hopefully, based off of our chemistry unit, come up with an explanation of why whatever happened, happened. Okay? Yes, Calvin? I'm going to get them just a little bit with the random group generator. Do you guys have any questions?
No.
Alright, safety. Safety. The little alien guy. First of all, you should know that he's mine. Alright? Be nice to him. But if you tip him over, he stops working. So there's like a little buzzer on the bottom of it, and if it flips over, it's kind of a safety thing, it turns off. So try to keep him up straight. And he does have a name. His name is Henry. Okay, so you can refer to him.
That's my uncle. My dad.
That's your name.
Hello, Henry.
Alright, now for groups.
Hello, Henry. How are you today?
And we have
How do you use the generator?
it's actually something that I downloaded online, so it just has like an algorithm where it does it.
I want it too.
You want it? What are you going to use it for?
I don't know. Just play Calvin.
Good, everyone's here. Christian and Christian. Oh, I saw Christian on there.
I think it's Lisa.
Don't take Christian away.
Christian's my friend.
Okay, hold on.
I just did.
Okay, 6 groups. You guys see that, or did I need to make it a little bit bigger?
Okay.
Alright. First group, Justin, Jack, and Shalley. Second group, Sanj, Angela, Jonathan, and Sophie. Group 3, Long, Alan, Pietro, and Ji-Young. Group 4, Calvin, Alessandra, Temu, and Sahil. Group 5, Gabriel, Charles, Shivanj, and Yuta. And group 6, Andrew, Jenu, Lakshita, and Tensio. Yes! There should all be yes! It's your Henry, what do we need to be careful with Henry?
Don't flip him over.
Don't flip him over.
And be very nice to him.
Be very nice to him. And also the big oil heater, since it's been on for an hour and a half, you guys can probably expect what is it going to feel like.
Hot.
It's going to burn. Don't touch it, okay? Alright. Alright, we're going to head to the lab and make sure you guys bring your paper and your pencil. Alright, before you guys start, there's a couple things that you want to be aware of. First of all, we're doing an experiment. How many independent variables can we have? One independent variable. What is that one independent variable?
The material.
Yeah, the material. Alright, the material is going to be our independent variable, which means everything else must be a what? Yeah, the same. What do we call those? Constant. Okay? So, I've already put sand into your beakers. However much sand you have should be how much water you have as well. Okay? Obviously the air, we can't measure that one out, but everything else should stay the same. That includes the distance from the heater. So you want to make sure all of them are the same distance from your heater. Everybody good? Do we have any questions? Alessandra?
Never mind, because it says 500 million. What happens if we die?
No, just 100. Yeah. All right. You guys may start. Is it heated up? Don't put that directly on there, Jenu. Thank you. It's not broken. It's working just fine. Oh, good. Why are you doing that, Sanj? Why are you using the ruler?
Because it says 10 centimeters.
You have to hold it.
Okay, again. You pause it like that. Okay. Stop it. I did stop.
Hi, Paige. Was my stopwatch not good enough for you, Jonathan?
30.
You don't know how many percent?
Oh, okay. Okay. Class. Okay. Most of you are about finished. Woo. Let's try it again. Okay, most of you are about finished. So what I need you guys to do, 2 things. Bring everything up here except for the heater. That includes the thing of sand, the empty ones that had the water and the air in it, and also bring up your stopwatches. I'm not sure. And the second thing, turn off your heaters. You guys can answer the question.
I can't go. Which one do you think would cool off faster? I think
Well, question for you guys. What happened? Which one heated up faster?
air.
Air. Why is that, do you think?
Because it's moved, the molecules it's less dense and it moves faster.
Okay, so you're just moving the particles faster. Which one was the slowest?
Water.
Is that what you guys thought?
Yeah.
You thought so? What do you think, Calvin?
I thought water was faster.
You thought water was fast. We're going to talk about why water is weird when we go back to the class.
In social studies, we learned that the water cools off and heats up slower than the land.
You already know then. You guys should have been able to answer this before we even did it.
Water cools off slower.
Class! Yes! Alright, let's talk about what happened. Okay, we all know that we had a little bit of a problem with the heat source taking too much power. That's okay, it still worked. We at least got 5 minutes worth of evidence. So what did you guys find out? Let's go ahead. Justin.
Air was a substance that heated up faster, and air is also the substance that cools down.
Yeah, I know one group had some problems just because of the type of heat that they had. But yeah, most of the groups found that air heated up the fastest. Which one was the slowest?
Water.
Okay, Long?
Water.
Yeah, water. So the reason this is, water is weird. It sounds like you guys learned a little bit about this in social studies. But what did you guys find out in social studies and from the lab today? Yeah, Charles?
Water heats up slowly.
Yeah.
Cools down slowly.
Yeah, does anybody know why? Yeah.
No, I forgot.
Okay? You guys are going to learn all about this when you guys get into 8th grade, and especially when you get into chemistry. But what you guys need to know now is that water is weird. Everybody say that. Water is weird.
Water is weird.
Yeah. Just like Justin. Just like
Man,
you
this
said.
is
You said it.
I did it.
Yeah,
If water is weird, why would we drink it?
Water is not weird in that it's bad for us, but it acts, as far as chemically, it acts very different than what we would think. So for instance, alright, what does ice do to water? Alright, it freezes up. Okay, that's all it is water freezing up. Usually when something is a solid, its density goes up. So it should sink, but what does ice do? It floats. That's one of the weird things about water. All it has to do with all the chemical bonds that hold all the water molecules together. But we won't get into all of
Last
that.
part of class.
We're going to go over the last 2 types of heat transfer, which we will be working on Friday, if you look at the backboard. And you guys are going to learn that from your favorite scientist, except for me. Beyond me. Who's your favorite scientist? Bill Nye, the Science Guy. You guys are great. Alright, you guys can go ahead. Justin, thank you. If you guys want to, you can come up here and sit. Just make sure, open your eyes and ears up there. Alright?
Miss Brunner is a really cool person. She's very enthusiastic and happy all the time, and she has one of the most positive attitudes that I've ever seen, ever. So that makes learning in her class really fun and always exciting and
positive
different.
attitude and makes class interesting.
I think Miss Brunner's classes are really fun. I've been taking her classes for 2 years now. She taught me 2 AP classes, and I felt like her teaching style really helped me, which was a lot of hands-on activities which helped me learn all of the different kind of labs that we are required to know for our AP, and that I felt like it really helped me do better online.
Mrs. Brunner is our PE teacher. She's really nice. encourages us a lot to have a positive attitude, and she has taught us hockey, badminton, volleyball, jump rope, and recently ultimate frisbee. And I really love her as a coach. Thank you, Mrs. Brunner, for teaching us. You're so nice.
Mrs. Brunner is a really good PE teacher because before I never really cared about sports, but now I'm much more into sports like hockey and ultimate
Mrs. Brunner for bio in 11th grade and AP Environmental Science. And she's always very positive and energetic, and she gets us excited to learn when we go to her class. And she always prepares for her class, like she'll always work on it over summer or before to plan all the PowerPoints or any worksheets, and she'll always ask us how can she help us better. She'll give us worksheets to work on, or she'll come in, when I was taking AP, she came in on the weekend to have a mock with us, and she always tries to make learning fun. I guess we play a lot of games, we do a lot of projects that are really fun, and I guess it's a different way of learning, which really helps because you are more involved. You're not just listening to a lecture, but you're actually working on it. So I really enjoy all of your classes.
You are a very good teacher and is very enthusiastic. And you let us play lots of games, and you are very nice.
Brunner is like an angel. She's always really nice in school, in classes. It's easy to understand, and even if outside of class, she always help us, and she's like an angel.